This video looks at the idea of implicit differentiation, and this is a situation where we have a function, an implicitly defined function, meaning that we can't express one of the variables separately, distinctively, or explicitly in terms of the others. So if you have a look at the situation shown here, we can't express this equation here in terms of a single variable, explicitly express it. We can't solve for y in terms of x only, or we can't solve for x in terms of y only. Okay, so what do? Can we still differentiate an expression like that? Okay, well, turns out we can, and it's through the process of implicit differentiation. We don't need to be able to explicitly write this equation in terms of one variable on one side and the other variables on the other. Okay, so what we can do, okay, is we go ahead and we differentiate as normal, but just something slightly different will happen. Okay, so we want to find dy dx. Okay, so we want the derivative of y with respect to x. But this is implicitly defined in here. This y is implicitly defined. We can't separate the y and the x's. So what we can do is we go ahead and we're going to differentiate the x's as per normal, but with the y, we're going to use a bit of a chain rule on it. Okay, so here, let's start with the first term. So I have d dx, okay, d dx here, and we're going to run that, if you notice, d dx through each of the terms here. All right, but when we come to the y's, y is implicitly a function of x. So we're going to deal with that in a slightly different way. d dx of x cubed, that will just give us 3x squared. No problems there, okay? d dx of y cubed. Now y is a function of x. All right? So how are we going to do this? Okay, well what we do is, it's the chain rule. It's 3 times y squared, okay, 3 times y squared times dy dx. Okay, similarly here we have an expression here which involves 3xy, both variables. Okay, so here's the product rule we'll apply. We'll take the constant outside because constants don't enter into the differentiation. The derivative of a constant is 0, so that drops out anyway. So we really want to differentiate x and y, x times y. So let's use the product rule. Let x be u, y be v. And so we have v du, well, dx is 1, so it's just y. We're left with a v, which is y times dx, which is 1, plus u, x, times dy dx. Okay, again, unknown at this stage, but that's all right for now. d dx of the constant 0 is 0. Okay, so we're left with all that. All right, next thing we can do, let's expand out the brackets. 3x squared plus 3y squared times dy dx minus 3y minus 3x dy dx is 0. Okay, so far so good. All right, next thing we can do, let's put dy dx on one side of the equation and everything else on the other side. So we'll keep this term here and this term here, keep it on the left, and we'll take the 3x squared and minus 3y onto the other side. Okay, changing their sign as we do so. Okay, next line down, we can factor out the dy dx. dy dx is 3y squared minus 3x, and that's equal to, on the other side, 3y minus 3x squared. Dividing through on the left-hand side by 3y squared minus 3x leaves dy dx on its own. We've transposed the equation. We have dy dx on the left on its own and everything else on the right. Okay, so we do have the derivative of the y with respect to x. We can cancel the 3's here, so we're left with dy dx is y minus x squared on y squared minus x. Okay, now, let's say we want to do something useful with that. We'd like to find the equation of the tangent at some given point. This point will be x is 3 on 2, y is 3 on 2. Now the equation we're after is the equation of the straight line tangent, y equals mx plus c. Okay, so it's going to be that form there, where m is the derivative of dy dx. That's the gradient, is y minus x squared on y squared minus x. We're going to substitute in 3 on 2 for x and same for y. As we work that through, 3 on 2 minus 9 on 4 and 9 on 4 minus 3 on 2. Okay, when we do that, we're going to work out that this is 6 on 4 minus 9 on 4, which will give us minus 3 on 4. And similarly here, this will give us 3 on 4 as well. So we find that we get minus 1. Okay, minus 3 on 4 divide 3 on 4 is just minus 1. And so the gradient m is negative 1. So our equation is y equals minus x plus the constant c, the intercept. Let's find that from the given point. X is 3 on 2, y is 3 on 2. Substitute those in. Plus c, that implies, okay, if you take minus 3 on 2 the other side, you'll get plus 3 on 2. That gives us 6 on 2, which is 3. So c is 3. And we have y equals minus x plus 3, the equation of our tangent.